Hey, hi there. This is Mr. Manley. Today we're going to talk about roots of unity, which is an extension of the topic complex numbers in trigonometric form. Now don't worry about the term roots of unity and exactly what that means yet. Let's start with something that you're very familiar with, which would be an equation like this. X to the fourth equals 1. And if we were presented with an equation like that, the natural question that would be asked would be, what is x? And of course we could say x is equal to 1. And someone might also notice that x is equal to negative 1. Now I want to make a brief aside here that somebody may have noticed a term from a long time ago called the fundamental theorem of algebra. All right. Probably not, but maybe someone does remember that. The fundamental theorem of algebra says that whatever the degree of the polynomial, that's how many solutions there are. Now you might also recall, probably all the way back in algebra, that you used to be asked sometimes to do these little notations here. dr. And what did that stand for? That stood for double root. And essentially, that had a meaning graphically, but in the context of the fundamental theorem of algebra, that was a comfortable little lie that we told ourselves. That 1 is a double root, negative 1 is a double root, therefore there are 4 roots here, and the fundamental theorem of algebra is being fulfilled with those 4 roots. Well, today I want to tell you we don't have to live with that lie anymore, because x to the fourth does have 4 solutions when we consider the complex possibilities. So it's not only it's not only 1 to the fourth that equals 1, negative 1 to the fourth equals 1, but also I to the fourth is equal to 1. And negative I to the fourth is equal to 1. So the fundamental theorem of algebra, at this point in your math studies, if you're in the section called Roots of Unity, or in the topic Roots of Unity, now the fundamental theorem of algebra is going to be complete, because we're opening up to all of these possible complex solutions which maybe we were open to before, but we didn't know how to get them. Let's look at another one, and then we'll refer back to that one that we're more comfortable with, the x to the fourth equals 1. This one's going to be a little bit more difficult. X to the fifth equals negative 1. So anybody watching this video is going to be able to say, yeah, negative 1 is a value of x. But based upon what I just said, there are 4 other solutions, because this is x to the fifth. And the fundamental theorem of algebra says that there are going to be 5 solutions. And we're not going to do any of this double root, or in this case it would be a quadruple root business, to lie our way through it. Let's go back to this root here, or this equation here. When I had x to the fourth equals 1, a way of thinking about it is that once I got 1 root, so let's say that that's 1, the other 4 roots on the real, imaginary, complex plane are going to be evenly spaced around the plane. So all I need to do is find 1 root, and then the other roots are evenly spaced. There's I, there's negative 1, and there's negative I. So once I find this one, I can think about the other 3 roots, for a total of 4 roots, are going to be evenly spaced about the real imaginary complex plane. Let's go back here. So I've got one root over here at -1. There are 4 other roots evenly spaced about the complex plane. Now, if those are evenly spaced, then I know these angles. 360 divided by 5. 72 degrees. Now, so the trick here is to take the first root that I've got, to take that first root and write that in trigonometric form. So this 1 here, this -1, it's going to be beneficial to me to write that in trigonometric form. So let's do that. So what would that be? It would be a magnitude of 1. The angle is 180 degrees, right? Because if it was pointing over here, if it was pointing over this way, that's 180 degrees. So that's the first one, the first root that I have. And all I need is 1. The rest are going to fall in line around it. I'm going to keep the magnitude, the same magnitude. If we look back at our picture, these all have the same magnitude, right? They're all magnitude 1. So I've got 5 roots here. There's 1, 2, 3, 4, 5. They're all going to be magnitude 1. So all I need is the angle. Aha. So what's the angle? And see if I can, I'm not going to be able to get into this picture really conveniently. Let me just draw a new picture here. So I've got the first root that I found is here. And then the next one, I go 72 degrees. So how does that work out in our solution? It's just cosine 180 plus 72. 250 degrees. 252 degrees. And then the next one is plus another 72. I'm going to go cosine. What is that? 324 degrees plus I sine 324 degrees. Now I'm not going to add 72. I'm going to actually go backwards now. So I'm at 180, so I'm going to go back to get that root, and I'll subtract 72 from 180. So this one, the root that's up in the second quadrant, I'm going to call that. All right, if I take these roots into, let's look at them in their, maybe not all of them, but look at them in their, so I've been saying trigonometric form. The other form we'll call rectangular, the rectangular form of the root. So I'm going to go back to the rectangular form of the root. Now this first one, of course, was -1. And think about, be sure you're clear on, I mean, it's very clear how we get that. The cosine of 180 is -1. So 1 times -1 is -1. And then the sine of 180 is 0. So I get 1 times 0 is 0 times I is 0. So I just have -1. Okay? So let's look at this. Let's just look at this other one here. Cosine 252 is -0.309. -0.309. And then the sine of 252 is negative 0.95. So that's going to be negative 0.951i. All right? So let me, I didn't know I was recording here. Hello, everybody. Okay. So now, if I take that and raise it to the 5th power, what's it going to come out to? Negative 1. Pretty neat. And then that'll work for all these other 5 as well. Those are called the roots of unity. So when I look at x to the 5th equals negative 1, and I say, what are the roots? Someone might say negative 1. When I say roots of unity, I mean, no, what are all the roots? And here's how we can find them. All right? Good luck.